Hello, today I'll show you how to make a visual programming system. It will be built from nodes, the connections between nodes. You can type the functions that you want to evaluate, and when you push eval, all your node graph will be evaluated. You can check. It shows the final value of this evaluation. It is 2500, and if we check it, it has 5 in initial input, then a function that squares whatever input it have, and then the function that multiplies by 100 whatever input it have. So 5 square 5 is 25, and it's multiplied by 100 is 2500. All's correct. You can drag the nodes. We can make a connections, and we can type a function that we want to be evaluated. For example, let's make a cubic function, and let's press eval, and it's also correct. 12,500. To implement this system, we need to think about 6 topics. Visual presentation, how our nodes will be drawn. The behavior, what will happen when we click and drag these nodes. A model that will represent our nodes. The model evaluation, what will happen and how these nodes will be evaluated. A connection. We need some system that will connect our visual representation with behavior and our model. And at last, we need a thing to set up all this. In a nutshell, all these node editing systems are directed graphs. And for the beginning, we'll look to the most simple case. Let's have a closer look to the nodes. We can see that most of them follow the same pattern. They have some inputs and some outputs. And in the most simple case, one input and one output. And this is the direct presentation of the function. And the graph is the composition of functions, where you put the output of one function into the input of the next function. And then in the end, you'll get the one big function composition. Like this in the math notation. To begin with, I'll stick with this design, where I have input and output, the header. I'll drag the node by the header, an input field where I can paste my function, and the action button, for whatever reason, for example, to check if the node is alive. Let's clone the project. Git clone, paste the link. Now let's open the folder in the Visual Studio Code. Let's start the terminal. Switch to the start branch. npm I to install the required dependencies. npm start. Run the live server. Let's check if it is working. Yeah, it works. Let's check again. Alright, works. Let's create a workspace. Just add 2 divs. And let's console it to check if everything is working fine. Yeah, it works. Let's create a node markup. I'll use the settings that I already figured out. This will be the node container. Create title. Next, we will encapsulate the HTML generation into a function. Let's make a node draggable. I want it to be draggable by title, and I will use the already existing solution. The idea of this code is that one div rules the position of the other div. Let's copy the code, paste it into the project. I will make a type any to get the Typescript out of the way. Now let's target the script to appropriate divs. Works fine. Now encapsulate this code into a function. Copy and paste. Now I will remove all the TypeScript stuff because I decided to leave it alone as JavaScript, at least for now. Pass the elements as arguments. Make a few changes to the code. Pass the required divs as arguments to the function. Let's check it. Works fine. Let's create a node builder class. It will take all the responsibility for the setup, so I can generate and set up as many nodes as I need. Create a file. Create class. Copy the code into a constructor. Add required paths. Parameterize the constructor, so I can put the ID and position information into the node builder. Parameterize the generateNode.html function. ID will be used to mark all the divs, and the position will be used for the initial position. Set up the drag behavior. Remove the old code. Create the nodes with node builder class. Works fine. Let's create node input and output slots. It will be made just by adding a few divs with some CSS setup. Alright, looks good. Let's make a connection between nodes. I'll use SVG line. And for the beginning, let's simply draw it. Okay, looks good. Now let's encapsulate this into a class and create two methods: initializeDraw and draw. InitializeDraw for SVG creation and draw for the line. I'm creating the ID property to touch the element by this ID in the DOM. Create a simple constructor. Create an initializeDraw method. Copy the code. And create a draw method. Find the appropriate SVG container and draw the line. Let's add the ID to the SVG container name. Remove the old code and make the connection. Okay, let's move on. Now let's make a connection line point from the output of one node to the input of the other node. I'm adding two keys from element and to element, where I will store the target divs. Let's pass them into the constructor. Initialize. Set the types. Select the required elements. Target the line ends to the centers of the input and output circles. Parameterize the line. The line is placed correctly. Now let's make it update on node movement. Let's implement connection update. Just for the test, I'll make it update on mouse move. The idea is simple. I will erase the current line and draw the new line when mouse moves. Create the erase method and simply remove the SVG line. Inside update method, erase and redraw the line. And let's update it on mouse move. Great, now it's updating. I want to implement the simple behavior. I want to click on output, then click on input, and then the connection line will be created. I will make this with the node connector class. It will have an input property, an output property, and if they both are presented, the line will be created. Let's create a node connector class. It will encapsulate all the logic related to the connection. All existing connections will be stored in a connections property. Initialize connections with empty array. Create connection method will create a new connection from element to element. Copy and paste the code. Create the workspace property. Pass the workspace to the constructor. Create two properties, from element and to element, where the current connection elements will be stored. Set input and set output methods will handle the connection logic. When I click to the output circle of the node from which I want to make a connection, I will call the node connector setOutput method and store this element inside the connector. Then, when I click to the input circle of the second node to which I want to make a connection, I will call the node connector setInput method. SetInput checks if output element is presented, and if it's so, it makes a connection. GetConnections returns array of all connections. Fix value. Now I want to implement the connection logic inside the builder class. At first I'm selecting input and output circles of the current node. Now I'm adding event listeners on click. When I click on output, I'm calling node connector set output. And when I click on input, I'm calling node connector set input. Let's create a node connector class instance. Pass the workspace to the constructor. And pass it to the node builders, so it can handle the connections. Fix the types. Let's fix some errors. I accidentally created my node connector class in a dist folder instead of src. Now I'll move it back. Fix the imports. Remove the code that I won't use anymore. Fix the parameter. Now I have working node connector. Let's make the connection update on node drag. Let's update node connections on node drag. I'll pass the callback function that will be updating the connections on node drag. Call it. Change the arguments list to the object. And pass the parameters. Just for the test, I'll pass lambda function with console log to see if it works. Yeah, it works. The drag message is in the console. Now let's dive into the node connector class. Fix the connection name. Add the connection to the connections array. Now let's write onDrag function that will iterate through all the connections and update them using update method of the connection object. Import the connection object for the type. Now node connection is working and it is updating on drag. Let's add another node to check if everything will work fine. It works. Very good. Now I want to change the connection name from random number to compose name, from ID to ID, to reflect the fact that connection goes from one node to another. Right now it's just a random number. Now I will create data node ID attributes in node output and node input. Get these attributes, pass their composition into the constructor as ID key, and remove the generate random number expression. Now the SVG line container ID is composed from IDs of nodes that it connects. Remove the commented string. Let's create a node model to store graph connections and node data. I will create a class with 3 private keys, ID, data and children, constructor, and getSet methods for them. Make a file. Create ID, data and children. Create constructor. Initialize properties in it. Create getSet methods. Create node model in node builder class. Pass the required data into the node builder constructor. This data is values and functions. Let's set up the node connector. So, when I make a connection between nodes, it will be reflected in node model. I will make one node child of the other node. Let's create private key nodes to store the node models, because node connector will store all of the nodes and it will handle all relations between them. Now I get the ID of the child node, the ID of the parent node, and if they are both presented, this means the connection is made and they add the child to the parent in node model. Create method addNode. Now when I create a node with a node builder, I add the node model to node connector. Let's console log parent node to see that when I make a connection, child nodes are added to the children key of the node. Okay, everything works as expected. Let's create an eval button to run the evaluation process. Let's create a function to evaluate node graph. It will be a recursive function that takes a node and the result of all of the previous evaluations. As always in recursive functions, let's make a terminating condition. If the node has no children, this means that this is the last node. If the data inside of this node is a function, call it and return the result as a final evaluation result. Otherwise, return node data. Now let's make a recursive step. Just copy and paste. If the node data is function, call it, store the result in a new value, go through all of the children and recursively call eval node graph for each child, passing the new computed value. If it is not a function, just pass the current data. Let's run the eval node graph and click on eval button. So we start the evaluation process of the nodes tree, starting from the root node. I need the method to get nodes from node connector. Let's create it. Let's create a constant root node where we store the very first node. Now I pass the root node and its data into eval node graph function. Console log the final value and console log the value of the current node. Run it and see the results. OK, working fine. Let's move eval node graph function into a separate file. Make a folder. Make a new file. Copy and paste the code. Add the argument type. I will refactor it a little bit, put the node data into a constant and access it with the getter method, and do the same thing with the node children. Put the correct arguments into initial call. Set the import and export. Test the work. All fine. Let's create input field in the node so I can interactively enter functions or data. Copy and paste input and wrap it with the div tag. Let's set up input events. Inside the node builder, I'm creating a constant where I will store the content of the input field. Add event listener on input and console log it for the test. Set the type to any to get it out of the way. It works fine. Show the data in the input field value. Set the type of the node input field as HTML element to get rid of the type error. Now I see the initial data in the input fields. Change the input event from input to change. And set the node data on input change. Test the program behavior. Okay, it's none, because I need to eval the input expression. Add the eval function. Check it again. Now it works fine. I will console log node get data just to see the input behavior. Okay, it works as expected. Let's create an action button. I will just insert div with styling and a wrapper around it. Okay, looks great. Let's add onClick handler to action button. Get element by ID, store it in the constant. Add event listener on mouse down and console log the current node data. Okay, looks good. Let's log evaluated result in every node. Change the log message in terminal condition. And add the log after node function execution. Okay, graph is evaluated correctly. Okay, this is the end of the first part. See you in the next one.